Assalamu alaikum. Welcome to lecture number 39 for the subject of software design and architecture. iTech 4129. I am your course instructor Fahad Anwar. So students, before I start my today's lecture discussion, I would like to give you a little bit recap about our last lecture. So students, if you remember what we discussed in our last lecture, we see about what actually are the tangling and scattering. I also give you an example for tangling of buffer management, and for scattering we see how it actually implements these secondary concerns. And then we see about aspect weaving, and then we see how software engineering is done with the help of aspects, where we see core system with some extensions as well. And then we see requirement engineering in terms of concern orientation, where we utilizes normally viewpoints. And then at the end of lecture I give you a inventory system, where we have some core requirements and extensions requirement as well for your self study. And now students, now what we are going to discuss in our today's lecture. So here is a brief agenda, or you can say objective of our today's lecture discussion. Now in this lecture we will see aspect oriented design using UML, and then we discuss some aspect oriented design process model, which is actually provided by Ian Somervell. And then we see some design model for that generic aspect oriented software engineering with aspects, where we discussed about core system with functions. Now here I will provide you some design model for that aspect orientation. And then at the end of our today's lecture I will provide you some kind of language support, what kind of languages are available to implement aspect oriented programming. So students, this is a brief objective of our today's lecture discussion. So let's formally start our today's lecture. So the next one is about this case study which I gave you last time. This is actually about inventory system. So there are basically two core requirements, C1 for first core requirement and C2 for second core requirement. And first core requirement is actually about the system shall allow authorized users to view the description of any item equipment in the emergency service inventory. And the second core requirement is about the system shall include a research search facility to allow authorized users to search either the individual inventories or the complete inventory for a specific item of equipment or a specific type of other types of equipment, you can say. So here it is a repetitive, so please ignore the typical mistakes over here. So students, basically these are the two core requirements. So what are these, so what kind of requirements these are? Students, functional, these are the functional requirements or non-functional requirements? Yes, these are functional requirements, because these are the primary concerns, because they are providing the services to the system. So anything which is actually provided by the system, what kind of services will be offered by the system, what the system shall do, is actually our functional requirements. And non-functional requirements are usually our quality related requirements, which are implemented at the system level, like reliability, performance, scalability, traceability, portability, interoperability. All of these are different non-functional requirements which are achieved at the secondary concern level, and these are hard to measure and hard to achieve. But these two core requirements are basically our functional requirements, which actually tells about what actually our inventory system will do. So these services are actually provided by our inventory system. So these are our two core functional requirements. And the next one is about extension of first core requirement, and then the further extension of first extension requirement. So E1.1 actually indicates about the extension of first core requirement. So further it is describing that it also shall be possible for authorized users to place orders with accredited suppliers or for replacement of items or different equipments, etc. And now for this extension of first core requirement, there is further extension of first core requirement. So here you can see whenever an item of equipment is ordered, so it should be allocated to specific inventory and flagged in that inventory as on or order, etc. So basically the purpose this is to tell you about the core requirement, core functional requirement, and now the next extension of these core functional requirement and the further extension of first extension of core requirement. So this is actually about inventory system. I am not going to more detail about this. So now here I am moving towards the our main theme. So students, so students, now we are discussing about aspect oriented design. So student, what actually the aspect oriented design? So aspect oriented design, we can say, is basically a process of designing a system, like we can say, which actually makes the use of aspects to implement the cross-cutting concerns and extensions that are identified during the requirement engineering process. Cross-cutting concerns we see in the inventory system over first core requirement, and second core requirement over cross-cutting concerns at primary level, which are over functional requirement, and then the second extension which also identified from the core requirements that are identified during the requirement engineering process as well. So if we discuss about this diagram, so students, this all of you, we already have been discussed about unified modeling language. So for use case diagram, what kind of requirements are used? Yes, functional requirements are always described with the help of use case diagram. So this use case diagram actually use case diagram actually tells us the how the user will interact with the system and what kind of services are actually being provided to the user. So students, in 2004, Jacobson was the person who actually provided a way how use case can be used in aspect oriented design and architecture. So this Jacobson person is actually suggested that like each use case actually represents an aspect and propose extensions to the use case approach to support join points and point cuts. So actually they also introduce the notion of use case slices and use case modules as well. So actually these actually includes fragments of classes which actually implement an aspect. So these can be composed to create the complete system. So if you see into this diagram, basically this diagram actually students shows that three use cases that you can say might be part of the inventory management system. So these actually reflect the concern of adding equipment to an inventory and ordering equipment as well. So equipment ordering and adding equipment to a store and related concerns. So once ordered item have been delivered, they must be added to the inventory and delivered to one of the equipment store. So all of this use case actually all of this use case actually showing this. So on the right side you actually have a operator which is your actor. And what is a actor operator? Primary actor or secondary actor? It depends on the requirements. So students, as you can see in this diagram, so this we actually discuss about how use case can be used to represent different aspects. So this representation of use case to represent different aspects is actually being provided by Jacobson in 2004, and this is the representation of how use case actually implements the core functional requirements. And if we talk about the further extension of requirements, so if we look into the extension as we discussed earlier about inventory management system, where we see extension of first core requirement, and then further we see extension of first extension with first core requirement we see. So if we see in this figure, which actually shows how the placing of an equipment order actually extends the core use case for adding like equipment to a specific store. So we can say if the required equipment to be added does not exist, it can be ordered and added to store when the equipment is delivered. So during the, we can say, during the development of use case model, you should students look for some common features, and where it is possible, structure the use case as core plus its extensions as well. So cross-cutting concerns such as the logging of all the transactions can also be represented as extension use cases as well. So basically in 2004, Jacobson actually provided the way how cross-cutting concerns where actually we contain a primary concerns which we call the functional requirements, how it can be represented with the help of use case. So here Jacobson provide a way how use case can be represented in aspect oriented engineering as well. So we can I can conclude that use case basically as an approach which can be served as a basis for aspect oriented software engineering. So each use case actually represents an aspect. So and further extension use cases which are our secondary concerns naturally fit the core and extensions of architectural models as well. So this is about extensions of use cases in the light of Jacobson discovery, how aspects can be representative in terms of secondary concerns, which we also known as extensions of our aspects as well. So here is a student's generic aspect oriented design process, which is actually provided by A.N. Somervell in software engineering. So here you can see that this author actually provides generic aspect oriented design model, which actually it is a linear process model. You can see that there are different stages of actually it involves 5 stages, if you can see over here. So basically developing of effective process for any aspect oriented design is very important. So if aspect oriented design is to be accepted and used, so this is actually suggested by this author is that aspect oriented design should at least include these activities so that it can be accepted by the aspect oriented community. So what are actually their stages? So let's discuss these stages one by one. So the first one is about core system design, which actually contains about software requirements. So at this phase, if I explain students, you actually design the system architecture to support its core functionality. So architecture must also take into account quality of service requirement like performance, dependability requirement, etc., because it is our core system design. And then is our aspect identification and design. So if we talk about this aspect identification and design, actually it starts with the extensions which we identified in the system requirement. So you should analyze these type of things, students, to see if they are aspects in themselves or if they should be broken into several aspects. So if they are core requirements, so it's okay. So if they are have further extension requirements, so you should further break down into several aspects. So once aspects have been identified, so these can be separately designed, which can be taken into account the design of the core system feature as well. So it's a responsibility of aspect identification and design. So basically in this aspect identification, you need to identify the aspects. If one aspect have further extensions, so you just need to break down this aspect into multiple aspects. So this is the basic task of this purpose, is to identify core and extensions of different aspects. And the next one is about composition design. So students, basically at this stage you actually analyze the core system and aspect design to discover like where the aspect should be composed with the core system. So necessarily we can say actually you are identifying the join points in a program at which aspects will be woven. So these join points, advices, aspects, concerns, weaving, all of these are basically the, you can say, keywords of this aspect oriented programming. So these are actually using again and again. So I am hoping that now you are well aware about these terms, because it's our second week about aspect oriented studies. So the next point is about conflict analysis and resolution. So what actually we done in this phase? So basically students are normally, a problem with aspect is that like they may you can say interfere with each other when they are composed with the core system. So conflicts usually occur. So when there is, we can say, a point clash with different aspects which specifies that they should be composed at same point in the program or not. So we can say there may be some kind of subtle conflicts as well. So when aspects are designed independently, so they may make assumptions about the core system functionality like that has to be modified. So however like when several aspects are composed, So one aspect may affect the functionality of the system in a way like that was not anticipated by other aspects. So the overall system behavior may be like not be expected as it is. So there is a need to be issue resolve this issue about conflict, which is actually resolved by analysis, and then we provide a solution which actually leads toward the resolution of that conflicts which actually occurs. And after we analysis this conflict, and we try to resolve this conflicts in the resolution part. And then the next one is about name design. And what is actually about the name design? So here it is actually about program naming standards. So what actually in this is this name design? So this is important design activity. Students, basically this defines different standards for naming at active and naming entities in the program. So this is very important, students, to avoid the problem of accidental point cuts as well. So these usually occur when you can say at some program like join point, like same name accidentally matches data point cut pattern as well. So the advice is therefore like unintentionally applied at that point. So obviously this is undesirable and can lead to unexpected program behavior. Therefore, students, the industry personals or the researchers community suggests that you should design a naming scheme that can minimize the likelihood of this happening, as we explained in the name design convention as well. So student, this is basically a aspect oriented design process, and all of these activities must be included. So that's why this design aspect oriented design process approach will be accepted by the researchers and communities only when these kind of stages are actually involved in your design for your company. So students, here is an aspect oriented design model. So in our last lecture we discussed about what are the core systems with these extensions, and now that core system with these extensions is now is I am going to provide yeah, I am going to map the system on the inventory management system. So here is a aspect oriented design model for inventory management system. And core and extension requirement you are already have been seen in previous slide of about what are actually core and extension requirement of inventory management system. So students, let's discuss this as well. So students, basically if you see into this diagram, it is actually tells us about the aspect oriented model. So in this diagram actually I use the unified UML stereotypes for an aspect which is actually proposed by Jacobson, as we discussed earlier. So this figure actually shows the core system for an emergency service inventory plus some aspects that might be composed with that core named as its extensions. But in this picture I only show some core system classes and some aspects. So this is a simplified picture, as you can see. This is basically a complete model which could more include more classes and aspects as well. You can note here that students, I used UML nodes as well. So I am assuming here that unified modeling language have been discussed in very detail in our second and third week lecture. So here you can students, you can see that I have used UML nodes to provide additional information about the classes that are cross-cut by some aspects. Additional nodes you can be see in the equipment location platform as well. So these are the different nodes, and aspects like maintenance, availability, ordering and monitoring, these are our aspects, and platform is our joint point, and equipment location is over another join point. Okay students, so here is not a place where I can describe about more detail in aspect. If so here if you can see the extension aspect of maintenance, so here I cannot display into similarly in this diagram this aspect extension is actually I am explaining in next slide. If you can see here, this is a aspect of maintenance. So if you see in this diagram, which is basically a more detailed model of an aspect, here I am discussing the aspect of maintenance. So from where I took this is an aspect of maintenance on the top left side, if you can see. So this is a more detailed model of an aspect. So likely we can say before, like you design aspects, you have to a core system design. So students, the first section of this aspect actually sets out the point cuts, which actually specify where it will be composed with the core system. For example, if you can see here, over if you will look into this diagram about the model of this inventory system, the point cut actually specifies that the aspect may be composed at the call get info method or join point, etc. The the following section actually defines the extensions. As you can see, the view maintenance history, it is basically an extensions like that are implemented by the aspect. So in this example, the extension statement is written in some kind of, you can say, uh, in some less than and greater than brackets or some tags as well. So normally this extension is read as in this method view item, this is in this item, in this method it can be read as like the in the method view item, after the call to the method get item info, a call to the method display history should be included to display a maintenance record. So this extension viewpoint is read in this way. So basically this is an aspect of maintenance represented in this aspect oriented design model of inventory management system. Here we have not enough space, so that's why I am explaining one aspect of maintenance about how actually it actually contains about the point cuts, join points, and the further its extension. So it is actually the idea about how aspect oriented design model we can be implemented for some system who have a core requirements, and you can say who have a core system and its extensions as well. And you can see aspects are actually represented by the extensions are actually represented by the aspects. And these aspects are what kind of aspects? These aspects are over secondary concerns, which actually showing the non-functional requirements like maintenance, monitoring, availability, and are over non-functional requirements. And if you can see, ordering and monitoring, two functional requirements. So maintenance and availability are two primary aspects, and monitor and ordering are over two monitoring and ordering are our two primary aspects, which are actually showing the functional requirements, and maintenance and availability are our two secondary aspects, which actually shows the cross-cutting concerns, which are actually our non-functional requirements. And for your better understanding what actually these aspects contain, I explain here in this diagram about the aspect of maintenance, and here we see about the what actually behind working in this aspect of maintenance. So I hope so you understand this very well. So student, now we are moving towards the end of our today's lecture discussion. So students, here are different programming languages which are actually available. If we so this is, you can say, a language or tool support is available for aspect oriented programming. So these are the different tools are available, or different languages are actually supported by aspect oriented programming. So all of these tools are actually being utilized, so you can utilize any of these tools according to your needs, requirements, or your company's requirement. So now students, we are moving towards the end of our this week lecture about. So basically where we have some I am concluding my talk over is that as we discussed about cross-cutting code as well. So basically where we have cross-cutting code, it also have some kind of consequences, like some kind of, you can say, drawbacks or disadvantages, like cross-cutting code in over entire different components can be cause of redundant code, like same fragment of code in many places. Like it can also be difficult to reason, like it is also difficult to change as well. So inefficient when constructing code is not needed is basically the main consequences of these cross-cutting code. So now I'm giving you a concluding remarks. So we can say this aspect oriented design and architecture is a new paradigm. So we can say a new way to think about programming. So you should clear your mind. This aspect oriented programming are not going to replace the object oriented programming concept, but this aspect oriented programming actually complements to as object oriented programming. So we can say this aspect oriented programming is similar to like event handling, where we have events are defined outside the code itself. So if we talk about this aspect oriented programming, we see about their main benefits. Aspect oriented approach, like it supports the separation of concerns, like by separating cross cutting concerns as aspects, individual concerns can be understood, reused and modified without changing other parts of the program. So students, this is the over my concluding remarks about aspect oriented design and architecture. So student, in this week we discussed about another software reuse landscape. So far we discussed about software product lines, then we discussed about model driven architecture, and now last week and now in this week we actually discussed about aspect oriented programming, and we specifically discussed this aspect oriented programming with the help of UML, specifically in terms of design and architecture as well. So students, till here our lecture number 39 is ended.